Hello everyone, I am Sudhnani, Assistant Professor, Department of the Civil Engineering, and in this video I am with one of the interesting topic, that is discharge over broad crested weir. Okay, in some of previous videos, please if you missed those videos, please do watch the triangular, rectangular and trapezoidal, and after this we are going to study about broad crested weir. In the name itself there is a meaning for this weir, broad crested weir. So I am drawing here. So just the brief figure of the broad crested weir. So water flows over this. The head of the water, the height of the water before the crest is how much? That is capital H. On this water flowing, on this is the small h, and the water flowing with the velocity v, and this datum is how much? H, and the length of this is L. Broad crested weir. Till now, and all the weirs we studied, there is a crest. Where was the crest? Can you find in the figure where we were finding the crest? The crest were here. Okay, that was here as we know. Now they are telling broad crested. The crest we had already here, the crest is there, but how it is? This is very broad. So that length I am going, this is the crest, that is how much length? L. So this is the head of the water, over the crest is H, the water flowing over that with the velocity V. Then what is broad crested weir? How to say this is the broad, which is the narrow? So one, the small trick is that if the 2 times of the length is higher than the head of the water, the height of the water, if it is, then we call it is as broad crested. Okay, then reverse of this, then it is the 2 times of the length is less than the height of the water, then it is called as narrow crested. Now it is clear what we are finding here. Again I am going to the title, discharge. So discharge we have to find here. Let's we have the derivation step by step. For this I need your attention, just little bit mathematical simplification is required for that. Let's we solve all together, just concentrate here. Now I am going to apply the Bernoulli's equation. For before the crest and after the crest. Before the crest is that this is the water is to be in the rest, no any the pressure exists. So I am giving the velocity is 0 and the pressure is also 0, but head is present. Head is present. Can you see the figure? The before the crest, how much is the head? Yes, head is H. So I am giving this is as a H. So this side is over. Now I am going to this side. Here is there any of the velocity? The pressure is 0. So I will keep it as a 0 plus. Is there any velocity over the crest? Yes. Can you find the V? I am written in this figure. So this is the water. I will indicate like this. So this is the V. So I will write V square by 2Z plus. Is there any head over the crest? Yes, you can find the head, that is the small h. Now I will simplify this. I want V in this. So now I will write h minus small h is equal to V square by 2Z. If you find the V in this, it gives V is equal to square root of 2Z into h minus h. This is the V. Now we are finding the discharge, that I will write it is as Q. What now? The task I am giving, just glance yourself what is the equation for the discharge. The same thing I am giving the clues now. The same equations you applied in the triangular notch, rectangular notch, trapezoidal notch, and also in some of the devices like venturimeter, pitot tube, you apply the same, the discharge. So, discharge we are going to find, just glance yourself how we derived. Yeah, I hope you found the answer. The discharge is how we can write CD into area into velocity. Which area? Which is the broad here. We are dealing specifically with the crest. So, area of this part. I am considering this as a triangular. So, now I will write CD as it is, and the area of this, the length is how much? L, and the height is how much? The h, and the velocity we already found here, that is v is equal to square root of 2z into h minus small h, the q. Let's start the derivation. Please concentrate on the how I am solving, how I am simplifying the equation. Now, how I can write this is as CD into L. I am taking h terms into it, the only one term I am making. So, I am taking into inside the square root. So, how it become? The 2z is a separate, I am taking in, so it will become double. So, h into h square into h. Now, I am completing the square bracket. Now, the one question I will ask you is, just you try to ask yourself, I will give the some of the clues. So, where we can get the maximum head, the maximum discharge, how we can get, which term is related among this CD, L and this term, which we can take it is as a limit. The maximum height, it depends upon the length, whether it is depends upon the h terms, it means the head terms. If you see here, when water flows over the notch, whether it depends upon the length or else the height, discharge. If you are fine, the answer is h. Yes, you are right. It is the h. So, what I am making means, I am taking this is the maximum discharge we can achieve when we get the, if the h is maximum, so we can get maximum discharge. So, d by dh of what term I am taking? H into h square minus h cube is equal to 0. So, I am differentiating this h into 2h minus 3h square is equal to 0. How I can write this is 2h h minus 3h square is equal to 0. So, 1 h take outside, take common and send it to the right side. So, h will go cancel. So, I am remaining h minus 3h square is equal to 0. Now, 3h square is equal to 2h. So, h is equal to, okay, 1h you get answer, this will you get 1. So, now only h I want, 2h divided by, if you send this is the 3. So, this is the h value. How the length of the derivation increasing? Please keep it in the mind. You should know this. After that, what you want? Area you want. Area you know, then that's why. Velocity we want. So, velocity, find the velocity, you have to go to the Bernoulli's equation. Once you got the Bernoulli's equation, you substitute, and where you can get the maximum discharge. So, that term you differentiate, you will get small h. So, I will keep this equation as the equation 1. Now, substitute this value in equation 1. So what do you get? So Q is equal to, I am writing the remaining term as it is. So 2Z as it is. In terms of small h, what we have to substitute this. So capital H keeping as it is, small h is 2 by 3 capital H raised to how much? 2 minus this 2 by 3 into H raised to how much? That is 3. So I am completing the square. The one term I will write, that's the simplification I am doing. I will keep this 2z term outside. It's the remaining term, this h into h square, that is h cube, and 2 square, that is the 4 by 9, minus this 2 cube is 8 by 27 into h cube. So this term I am completing. Okay, fine. The next, the CD into L into square root of 2z, L into square root of 2z in the square root bracket, I am taking h cube, take it outside. The remaining term I am just simplifying, that is 4 by 19 divided by 8 by 27, I am completing this and complete root. CD into L into 2z, nothing new I am taking, just I am simplifying, you can see it is very well. H cube I will keep, this is as it is, just take the LCM. 12 minus 8 divided by 27, it will be. So CD into L into square root of 2z into root of h cube, this is 4 by 27 we get, so I will keep it as in the square root. Just simplifying, nothing new I am taking. So 2z, so this I will keep, this is h, this is the 3, if the square root is means 1 by 2, 1 by 2 into 3 is 3 by 2 I am writing, and the value of this 4 by 27 is 0.38. So take a constant term first, 0.38 CD into L into square root of 2z into h raised to 3 by 2. It is the final equation for the discharge over the broad crested weir. This is the brief, nothing is new. You have to consider, you have to keep it in your mind. It is the glance points and the key points I will tell you now. What we are finding? Discharge. Discharge, this point you know, and the area. What we are dealing here? We are dealing with the crest. The above the wall area we should consider length into height. If you take, that's a fine. Only the velocity term, how to find the velocity. The previously how we were keeping the velocity in triangular and rectangular, that is the theoretical value square root of 2gh. Here that is the upside thing. Instead of what we are doing, we are applying the Bernoulli's theorem to the section before the notch, before the crest and over the crest. So you will get the velocity. Just substitute, simplify, you will get discharge this. Thank you each and everyone, please follow, and before watching this video, please I request you to watch the triangular, rectangular and trapezoidal notch. Thank you.